In today's class, we are going to see the test of significance for single mean. So in our previous classes, we have seen the test of significance for single proportion, and also we have seen the test of significance for difference of two proportion. So in today's class, what we are going to see is the test of significance for single mean. Okay, so how do you identify this problem is the test of significance for single mean. So we'll read the question first. A data scientist claims that their algorithm processes data in an average time of 15 seconds. Okay, so what he says is the whole algorithm, it processes data in an average time. Okay, so this is like considering your population. So it is given that the population's average time, average is nothing but your mean. So in your problem, if mean is given, then you have to check whether one single mean is given or two means for two samples are given. Okay, so here reading the first line tells you that this is for the whole algorithm. So this means that this is for the whole population. Okay, so it is given that the average time of 15 seconds. So here, as I told you, for the population, mean would be considered as mu. Okay, so mu is given as 15 seconds. Next, a random sample of 36 runs. So a sample of 36. So what does this 36 denote is your n value. So n is 36. So here if you see n is greater than or equal to 30. So from this you can identify the problem is a problem of large sample. Okay. So a random sample of 36 runs of the algorithm yields an average processing time of 17 seconds. So for the sample, the processing time is 17 seconds. So therefore, your x bar will be equal to 17 seconds. Okay, with a standard deviation of 3 seconds. So this is for the population. So population standard deviation is denoted by S1. So S1 is given as 3 seconds. Okay, so here in the large sample, you have a population mean and a sample mean. So when this is the case, then it is the test of significance for a single mean. So single mean is you have only one sample, right? So it is the test of significance of single mean. So you will be using the first formula here. Okay, so now as usual we'll write what is our step 1, step 2 and step 3. So step 1 is your null hypothesis. As usual, what do you state your null hypothesis? There is no significant difference So there is no significant difference because you are going to compare here the sample and the population mean. So you will write between sample and population mean. So in the other way you can write it as mu is equal to 15 seconds. Okay, you are saying that there is no difference. Whatever the scientists claim, you are accepting as it is. Okay, now coming to your alternative hypothesis. So it is just the opposite, the complement of your null hypothesis. So here you'll write there is a significant difference. Difference between sample and population mean. The other way you can write it as mu is not equal to 15 seconds. Okay, so next is writing your step 2 level of significance. So if you read the question, nothing related to your level of significance is given. So if nothing is given, you will default consider the level of significance alpha is equal to 5%. Okay, so here coming to your alternative hypothesis again. So if you write mu is not equal to 15 seconds, you know that it is a two-tailed test. So only if you have less than and greater than, then you have a single tail test. Since it's not equal, your alternative hypothesis, you are taking it as not equal. So you say that it is a two-tailed test. So here you have the table, and for 5% level of significance for a two-tailed test. So you can see for 5% level of significance in your two-tailed test, the table value is 1.96. So you can write at 5.5% it is equal to 1.96. Okay, now you've already identified that formula 1 is that you're going to use. So step 3 is calculating your Z value using your calculated the formula. Okay, so here we are already written, right? That is our x bar. What is our x bar? We have written it as 17 seconds. Our S1 is equal to 3 seconds. Mu is equal to 15 seconds. So all this is already given from the question. So substituting this value, so it will be 17 for x bar minus mu is 15. You don't have sigma here. Instead, you have the standard deviation of the sample. So when the standard deviation of the population is not given, you can consider the standard deviation of the sample itself as the standard deviation of the population. So here S1 will be equal to sigma, which is equal to 3 seconds. That is 3 divided by, and n according to the problem it is 36. So it is root of 36. Okay, so 17 minus 5 will give you 2, 3 divided by 6. So 2, 1 by 2 will be equal to 4. This is your calculated value. Okay, so step 4, what you do is, you compare the table value and the calculated value. Okay, so according to the table value was 1.96 and your calculated value is 4. So if the table value is greater than your calculated value, means we'll accept H0. But in this case, 1.96 is not greater than 4. So what we do is, we reject H0 and accept H1. So it means that according to the hypothesis H1, we have written as there is a significant difference. Okay. So there is a significant difference between sample and population mean. That's all.